Hey kids, so today what I want to walk you through on this beautiful Cinco de Mayo, May 5th, is the Seasons Lab. So in HMH there's a hands-on lab that really goes through how we get seasons. And that really is kind of our target for this week. You're going to be assessed on it later this week. So I want to walk you through virtually uh, the hands-on season lab. It's more hands-on for me than it is for you, but I just wanted to throw this together so you can kind of see. I think it's a good visual of how we get seasons. So the setup here with for materials, I didn't go with the materials that HMH gave us. I just used materials around my house. I think it's going to help regardless. So what I did is I took my crossbow out, I shot through a softball. That softball is going to represent the earth. And what I did is I drew a line around the earth, right around its belt, to represent the equator. That equator is really important when it comes to seasons. I also put the arrow in perpendicular to right through the poles on the earth. And then what I did is I drilled a hole in this piece of wood to represent the tilt of the earth's axis. So that's going to help us as we go around through the seasons. I also have a light source hanging here. That's a very bright light. That's going to help us understand how we get seasons. And then right underneath it, I got a piece of styrofoam. I know the lab calls for construction paper, but I have styrofoam. And I drew lines, kind of crosshairs, representing that 90-degree difference between seasons. So you can kind of see the blue lines here. So what I want to do first is kind of label those seasons so we can see what's going on here. So when we have this setup right here, the light, and then we have our earth, if you notice we're located right here, right up here, kind of on the laces here of the softball on earth. Now notice that if we draw a line from the center of the earth to us, it's going to kind of point upwards. Okay, and this really represents our winter solstice. So winter solstice, okay? This is the shortest amount of daylight we will ever experience because we're pointed away from the winter. On the opposite of that, we have our summer solstice, okay? So 6 months away from this winter solstice is the summer solstice. One way to remember this is Sol. Remember Sol, in fact, I just watched Aquila and the Bee with my daughter. Sol was one of those words that they mentioned that's all about the sun. So on the winter solstice, we have our shortest daylight. Days are real short here. And in the summer solstice, we have our longest amount of daylight. Okay, and if we think about the revolution of the earth around the sun, this is going to be our sun, of course. We go counterclockwise. So we have that movement here. Counterclockwise. So if you think about the seasons here, think about the seasons rotating around there. In between summer and winter, we're kind of there right now. We have our spring or vernal equinox. Okay? So I mentioned before that the equator comes into play quite a bit. And one way to remember the equinoxes is that sun is directly over the equator. So it starts with equator, and we think of equal day and night. Okay, so here we have about 12 hours of daytime, 12 hours of nighttime. Opposite that, 6 months away, we have our autumnal or our fall equinox. The setup is kind of the same, that the sun is sitting directly over the equator. Okay, so now let's get to the meaty stuff here and look at the motions here. So I have the light, which is lit up. It's pretty bright. I apologize if my camera's kind of influenced by it. And over here we have our sun, or earth, I'm sorry, this is the earth, set up in the winter position here. So if you look at what's happening in the northern hemisphere, again, we're kind of pointed upwards away from the sun. So we're experiencing that real short amount of daylight. You can actually see that terminator line right here. Okay, and this is that point where no matter the revolution of the Earth, the northern hemisphere, or even if you're up in Alaska, they don't really have daylight during the winter because of this. Okay, so remember the Earth spins, counterclockwise. This is one day. This is a position around the sun during that time. So this is a winter solstice. So as we move along with the seasons, the Earth's axis doesn't move. It stays tilted the same direction. Okay, always pointed in the same way. So if we set this up here, we see the equinox here. Okay, so this is at fall or autumnal equinox. That the sun is sitting directly over the equator. You can kind of see the northern and the hemisphere have the same amount of light. Okay, and as we keep moving, let's move the Earth around here. Okay, so now you can see the northern hemisphere. The northern hemisphere is pointed directly at the sun. Okay, you can see that position. So you can see that's our summer solstice. That's the amount of daylight that we have, or the most amount of daylight we have. Now notice that it's different in the southern hemisphere. They're pointed away, they're pointed downward. So this is our summer solstice is actually their winter solstice, okay? And vice versa. And as we move to our last position here, okay, completing that year out, well, not really completing it yet, okay? But we have that equinox happen again, where that sun is sitting directly over the equator. We have equal amounts of daytime and nighttime. And then as we complete, we go back to the winter solstice here. Okay, again, we're faced upwards away from the sun. That southern hemisphere is pointed almost directly at it. It's their summer solstice, well, it's our winter solstice. So it's not the distance that the Earth is away from the sun that causes the seasons. It is the tilt of the Earth that causes those seasons. If we were tilted in any way, any different direction, our seasons would be very different. So hopefully this demonstration gives you a pretty good idea of how we get those seasons. Right now we're getting warmer and warmer and warmer, so we're getting to that point where we're experiencing more and more daylight. About every day we get 2 more minutes of daytime, all the way up to that summer solstice. Once that summer solstice hits, then we start losing daytime all the way to the winter solstice. And that's really how a year works with seasons. So now that you've watched this, thank you for watching and being attentive. There is a short assignment attached to this video. So thanks for your attention. I hope everything with online learning is going well. I miss you guys a ton. It's not the same teaching online as it is in the classroom. I hope you're getting outside and enjoying the weather that's coming, and it's really nice. So take care, and we'll see you next time.